Just 4.2 light-years away from Earth, in the depths of the Alpha Centauri star system, lies a mysterious planet that has captivated astronomers and dreamers alike. Proxima B. This rocky world orbits the red dwarf star Proxima Centauri, the closest known star to our Sun, and from the moment of its discovery, it has stood out as one of the most promising candidates for the existence of extraterrestrial life. What makes Proxima B so compelling is not just its size, which is similar to Earth's, but also its location within the so-called habitable zone of its star, a region where temperatures might allow for the presence of liquid water. This alone makes it an object of intense scientific interest. But recent discoveries have elevated the mystery to a whole new level. Strange and unexplained light emissions have been detected from the planet's dark side, a region long thought to be barren, frozen, and lifeless. These emissions defy natural explanation and have led to speculation about the possibility of alien technology or other phenomena that stretch the boundaries of our current understanding. The proximity of Proxima B to Earth makes it particularly fascinating. In cosmic terms, it's in our neighborhood. If we could travel at the speed of light, we'd get there in just over 4 years. For comparison, it takes sunlight only about 8 minutes to reach us from the Sun. However, the similarities between Earth and Proxima B quickly begin to fade as we delve deeper into its characteristics. Unlike Earth, which enjoys the relatively calm and steady radiation from a stable yellow star, Proxima B orbits a red dwarf, a small, dim, and temperamental star known for its intense and unpredictable flares. These flares are not mere flashes of light. They are powerful eruptions of high-energy radiation that could strip away a planet's atmosphere over time. On Earth, we are protected from solar radiation by our magnetic field and thick atmosphere, but we don't yet know if Proxima B possesses a similar shield. Without it, any surface life on the planet would be exposed to lethal doses of ultraviolet and X-ray radiation, making survival on the surface unlikely unless life evolved to cope underground, beneath thick ice, or in other sheltered environments. Another complication is the planet's proximity to its star. Proxima B completes one orbit in just 11.2 Earth days. That's an entire year packed into less than 2 weeks. This short orbit places the planet extremely close to its star, much closer than Mercury is to the Sun. As a result, Proxima B is likely tidally locked, meaning one side of the planet always faces the star, bathing in perpetual daylight, while the other side is shrouded in endless darkness. On the bright side, temperatures could soar beyond habitable levels, and on the dark side, they could drop to hundreds of degrees below freezing. But in between lies a narrow region known as the Terminator Zone or the Twilight Belt. Here, where the scorching day meets the frozen night, temperatures might be more moderate and conditions could be just right for the presence of liquid water. Scientists believe that if life exists on Proxima B, this twilight zone might offer its only sanctuary. But even here, life would have to contend with hurricane-force winds, driven by the massive temperature differences between the two hemispheres, potentially making the environment extremely volatile. Yet, despite these seemingly inhospitable conditions, Proxima B continues to surprise us. With the help of advanced instruments like the James Webb Space Telescope, astronomers have recently detected unusual light signals coming from the planet's dark side. This region, long assumed to be dormant, cold, and geologically inactive, is now emitting light patterns that do not align with any known natural processes. These emissions aren't the result of reflected starlight, volcanic activity, auroras, or atmospheric lightning. They are not consistent with background radiation or cosmic noise. Instead, they appear to be intentional, structured, and consistent with the kind of artificial light you might expect from large-scale infrastructure, if such infrastructure exists. Some scientists speculate that this could be a sign of alien technology. Perhaps advanced beings harnessing energy on the planet's dark side or signaling in ways we don't yet understand. It is, of course, too early to jump to conclusions. The scientific method demands caution. Extraordinary claims require extraordinary evidence, and while these emissions are undeniably curious, they are not proof of intelligent life. Still, the possibility cannot be entirely dismissed. The idea that an advanced civilization might exist on a planet so close to us, and might be signaling across the void, is both thrilling and unsettling. Could these be attempts at communication? A form of signaling we're only now detecting? Or are they a byproduct of some unknown technology at work? Alternatively, are we simply witnessing a rare, unknown natural process that mimics artificial signals? These questions now drive the ongoing investigation, and the upcoming observations from the extremely large telescope, expected to begin operations later this decade, could bring us closer to answers. Even if Proxima B harbors no life at all, its study is invaluable. The very fact that a rocky, Earth-sized planet exists in the habitable zone of our closest stellar neighbor raises the odds that such planets are common throughout the galaxy. And if these planets are common, then perhaps life is too. With hundreds of billions of stars in the Milky Way, many of them with planets of their own, the probability that life exists elsewhere grows stronger with each discovery. Proxima B may be just one example in a vast and varied universe. Still, its nearness makes it special. It's the one we might visit first. And that nearness has inspired serious proposals for interstellar exploration. Projects like Breakthrough Starshot envision tiny spacecraft, each no bigger than a postage stamp, equipped with sensors and cameras and propelled by powerful lasers on Earth. These probes could travel at up to 20% the speed of light, reaching the Proxima system in just over 20 years. If successful, they could beam back images of Proxima B and provide humanity with its first close-up look at an alien world. Whether or not these mysterious light signals are artificial, the excitement surrounding Proxima B is justified. It represents a frontier, a boundary between the known and the unknown. Every bit of data we collect brings us closer to answering some of the biggest questions humanity has ever asked. Are we alone? Is Earth unique? Or is life, perhaps even intelligent life, a cosmic inevitability? Proxima B's harsh environment reminds us that life must be resilient, creative, and adaptable to survive. If anything lives there, it would have to endure radiation, temperature extremes, and atmospheric challenges unlike anything on Earth. But Earth itself has shown us that life can survive in boiling acid, in frozen deserts, and even inside nuclear reactors. Nature finds a way, and perhaps it has done so again, 4 light-years away. The study of Proxima B is still in its early stages. New discoveries will come, and with them, more surprises. Whether we're witnessing the glimmer of alien lights or simply uncovering new and bizarre planetary behavior, Proxima B teaches us to remain humble in the face of the cosmos. The universe is far stranger than we imagined, and the answers we seek might lie in places we once overlooked. Proxima B may be cold, dark, and stormy, but it also might be alive. And if it is, if we someday confirm even the faintest sign of life, then everything changes. Our understanding of biology, of evolution, of our place in the universe would shift overnight. For now, we wait, we observe, and we wonder. But one thing is certain: Proxima B is no ordinary planet, and its story is far from over.